Okay, so the last topic for tonight, we are going to talk briefly about probability. 40 easy steps. No. Probability is a lot simpler than that, trust me. Famous last words, right? Probability is how likely something is to happen. Probably one of the more basic, simpler definitions of probability is the proportion of times that it does happen.
Looking at different angles of the problem.
Kind of, yeah. So, what basic probability is looking at, what we have these events that we are looking at. An event might be drawing a number for the lottery or flipping a coin or whatever. And an event has outcomes. If we're flipping a coin, of course, those outcomes are either heads or tails. Has only two outcomes. And if those outcomes are what we call equally likely, assuming that the coin is a fair coin, the probability of that outcome, I'll call it outcome A, is equal to the number of ways A can happen divided by the total number of outcomes for that event. So the probability of flipping a coin and getting heads. Well, how many heads are on that coin? One. How many possible outcomes are there? Two. We're going to ignore the extremely unlikely outcome that the coin lands on its side. Very, very, very unlikely. But you can, but we're going to ignore that. Yeah.
Like you're reading my mind.
Rolling a die. What's the probability that we roll a 3? Well, how many 3s are on that die? 1. How many possible outcomes are there? Standard 6-sided die, cubical die. So 6. Good question. I was actually thinking the same thing. No 20-sided, no tetrahedral, no 4s, no 6, no 8, no. None of those. So yes, it is a 6-sided die. So 1 out of 6. And of course, we could convert that into a decimal if we wanted to, or a percent if we wanted to. So now let's look at something just a little bit more complex. We're going to put marbles in a box. We're going to put in 30 blue and 20 red. In the box. What is the probability that you will reach into that box if you mix them up good and you're not looking at all, assuming the red and blue marbles are exactly the same shape, size, texture, weight, everything else, just difference in color, that you're going to reach in there and pull out a red marble? Well, how many red ones are there? 20. How many total? 50s. 20 out of 50. Or 2/5, or 0.4 probability. Any one of those is acceptable. What is the probability that you reach in there and pull out a blue one? How many blue ones are there? There's 30.
30.
Out of how many total? 50.
50.
So 3 out of 5 or 0.6. Are there any other possibilities? If I reach in there and I pull out a marble, is there any other possibilities other than red or blue? No, assuming that nobody snuck a different marble in there. It's going to be red or blue, period. And that brings us to one of our rules of probability is the total probability of all the possibilities has to add up to 1 or 100%. Yes. So those probabilities add up to 1, which means that's the only possibility. There's no other possibilities. Let's say we reach in and draw out 2 marbles. I want to know what is the probability of getting the first one red and the second one blue. The answer is we don't have enough information right now. What do I mean we don't have enough information? Well, I have to ask the question, do we put the first one back before drawing the second? What do I mean? Well, if we do, if the answer is yes, we put it back. That is what is called with replacement. It's a technical term. You really don't need to know the term, but we put it back. We replaced it. If we replace that marble, okay, what is the probability of drawing that first marble red? 20 out of 50, right? Or 0.4. Now we put that first marble back. What's the probability of drawing the second marble blue? 30 out of 50 or 0.6. So the probability of both of those things happening is 0.4 times 0.6 or 0.24. Or we could do 20 times 30 is 600, 50 times 50 is 500, or 2,500 I should say. So 600 out of 2,500, which is also 0.24. That's assuming we put the first marble back before we drew the second. If we did not put it back, the answer is no. That is considered without replacement. What that means is, what's the probability of the first one being red? Still 20 out of 50. That doesn't change anything. But we don't put it back. What's the probability of the second one being blue? Well, how many blue marbles are in there? 30. But how many total marbles are there? Only 49. So that's 30 divided by 49. 0.6122. Now you'll see the probability of drawing a blue one on the second marble is actually increased because there's fewer marbles in there. I took out one of the red ones. It's gone. So this probability, I multiply them. If I want two things to happen together, I just multiply them together, is 0.2449. So it's slightly greater chance if I don't put that first one back, there's a slightly better chance that I'll get a red marble followed by a blue marble. Now I always get asked the question of, well, what if the first one was blue? Well, then we wouldn't have drawn the second one because we'd already failed. Does that make sense? The probability only works out if the first one's red, so we don't care if the first one was blue, we're done. This is what we call independent. When we did this drawing here, we drew out the first marble, we put it back before we drew out the next marble. So the probability of getting a blue marble on the second draw was just the probability of getting a blue marble, period. It was independent because we put the marble back. This over here, of course, is not independent. Depending on the textbook you look at, some probability or statistics textbooks will actually use the word dependent, and others will simply say not independent. But here, the probability of drawing out a blue marble on that second draw depends on what happened on the first draw. If we got a red, that probability goes up. If we got a blue, the probability goes down. Of course, if we got a blue, we don't care anymore, right? But that second probability depends on the result of the first action. If those two probabilities are independent, we can find the probability of two things happening in that sequence. We can just multiply them together. For example, if I want to know what's the probability of flipping a coin, flipping a tails, and rolling a die and rolling a 5. What is the probability of flipping tails? 1/2, right? What's the probability of rolling 5?
1/6.
1/6. So that's 1/12 or 0.0833 probability. Okay. For us, what's most important for us as far as probabilities is being able to read data out of a table. So let's say that you have, let's look at a company here. Let's say that in this company, we have employees that work on an hourly wage. We have some that work on a salary, and we have some that work on commission. We have employees that have a high school education or less. We have employees that have an associate's degree. And we have associate that have a bachelor's degree. So let's say that of the employees that work hourly, or that have a high school education, I should say, we have 114 of them work hourly, 6 work on a salary, and 4 work on commission. Of employees that have an associate's degree, 63 work hourly, 8 work on a salary, and 7 work on commission. Of our employees that have a bachelor's degree, 27 work hourly, 18 work on a salary, and 8 work on commission. This is what we call a contingency table. It shows 2 different variables, 2 different sets of classifications, and how they relate to each other. And to work with a contingency table, we need to find the totals of each column. So 114 plus 63 is 177, plus 27 is what, 204? 6 and 8 is 14, plus 18 is 32. 4 and 7 is 11, plus 8 is 19. So we total up each row. We can find a grand total. What's that? 236, 255 is our grand total. We also need to find the total of our columns. We found the total of the rows, so I find the total of the columns. So 114 plus 6 plus 4 is 124. 63 plus 8 plus 7 is 78. 27 plus 18 plus 8 is 35, 53. And that better also... What's that? Should this be 88? You are correct. Yep. That should be 88. And hopefully those all add up to 255 as well. They don't, do they? So let's see. We've got 124 is right. No, this is 78. That's why. That is 78.
Oh, yeah.
Okay, so then it does work out. So what we want to look at here is, let's see, what's the probability that a randomly selected employee has one works on salary. Well, works on salary, that's this row right here. There's 32 people that work on salary. Out of how many people in the company? 255. So this is literally going to be 32 out of 255, which is 0.1255. It's standard to round probabilities to 4 decimal places unless you're told otherwise. So I'm going to erase this stuff quick here. My next question, what's the probability that a randomly selected employee has an associate degree? Well, again, this is the column as associate degrees. There's 78 of them out of 255. So that's 78 out of 255. .3059. So about 30.59% have an associate degree. So you guys get the picture there, right?
Yep.
So now let's look at another possibility here. What is the probability that a randomly selected employee has just a high school education and works on salary? Well, if we go up here, high school education is right here. Works on salary is right here. The only ones that do both are the 6 out of 255. So that's 6 out of 255. Obviously going to be a really small probability. 0.0235. So about 2.35% of our employees have both a high school education and work on salary. Oops. I erased something I shouldn't. Bless you. So when we're doing that type of situation where it's an and, it's where the two things cross. That's why it's called an intersection of probabilities. If you were to take a formal probability course, they would actually call that an intersection. What is the probability that a randomly selected employee has a bachelor's degree and works hourly? So we don't need to highlight the two columns, do we? We got bachelor's degree and hourly, that's 27 out of 255. $27 divided by 255. 0.1059. What is the probability a randomly selected employee has a high school education or works on salary? What's the difference between this one and the third one up here? Yeah, one is an and up here. This was and, had to have both. This is or. It can be either one. So if we go up to our table up here, high school is this one, salary is this one, and it can be either one. There's two ways I can approach this. I have 5 numbers here that I could add together. I could add all 5 of those numbers together. That would give me how many have either a high school education or work salary. Of course, that's out of 255. So let's look at doing it that way first. So what do we have there? 114, 6, 4, 8, and 18. 114 plus 6 plus 4 plus 8 plus 18. Did I get those all right? 6, 4, 8, 18. Yep. If I add that up, I've got 24. Is that 150?
156.
156?
So you could just take the 32 plus the 124.
Give me a second and I'll come back to that.
Okay, okay.
Well, why do you have the 4 in there if that's for commission?
Because they're on high school, they still have a high school education. It's either a high school education or work on salary.
Okay.
156 isn't right. It's 120, 124, 132, it's 150.
Oh yeah, we don't add the 6 twice. Yep, you're right.
So it's 150 divided by 255. So you get 0.5882. What you tried to do there was you tried to do, and that's where I was actually going next, so I'm glad you did that. You tried to do this. Get off there. You tried to just take 124 total for high school and 32 total for salary and add them together, didn't you?
Yeah, and that's why I double the number.
The problem is, exactly, the 6 is counted in both. You can do that, you can add those totals together if you go back and subtract out the 6 that was counted twice. Now if you add those up and subtract the 6, it's still 150 out of 255. If this were a formal probability class, we would call that, and I'm not even going to write it down, so you don't have to write it down either. It's actually called the Inclusion-Exclusion Principle, where you add together those totals, but you got to exclude the things that have been included twice. If it's included in both of them, you've got to exclude it from your total to make everything work out.
That's how you got 6.
That's how I got the 6, because the 6 is the number that's counted in both of them. Okay, let's look at another situation here. Now I'm going to show you some notation. What is the probability that a randomly selected employee works hourly given they have a high school education. What does this mean? That means it works hourly given they have a high school education. That means we are no longer looking at the whole 255 anymore. When we said given they have a high school education, what we are saying is we are now only looking at that column right there, those that have a high school education. How many of them work hourly? 114 out of 124.
124.
Yeah. So what we're done is we've limited the scope of what we're looking at. So 114 over 124. .9194. So there's a high probability, if we know somebody has a high school education, there's a high probability that they're working hourly in this company. So let's play with that a little bit. What is the probability that someone has a high school education given they work hourly? Let's go to the other end of this. Now, what are we focusing our attention on? It's given that they work hourly. So this time, we're only looking at those that work hourly. So we're only looking at this row. How many of them have a high school education? 114 out of the 204. You need me to slow down for a second?
That'd be nice, yeah.
Okay.
It's what happens when you write something down, I'm writing it, and then you're moving to the next step.
Okay. Let me just write this down quick. We have the 114 here out of 204. So what we've done here in both of these cases, when we say given, it means we're not looking at the whole group anymore. We're not looking at the 255 in this case anymore. We're focusing on that group where it says given. Given high school, and did they have a high school education? That means we're focusing on just those 124 that have the high school education. Given that they work hourly, that means we're focusing only on those 204 that work hourly. And in that group, 114 of them meet the other equality. So this is going to be 114 divided by 124. Not 124, sorry. 114 divided by 204. 0.5588. Any questions? Being able to pick numbers out of a table like this is very important. What we did here is just touching on it. I mean, this is the probabilities and stuff like that. There's way more you can do with one of these tables. This contingency table here is a very powerful tool. If this were a formal statistics class, and thankfully it's not, there are actually calculations you could do to see if there really is a relationship between the two variables, if the level of education actually does affect how they get paid at their job. And there's a lot of things you can do with these tables. So the big question is, you guys understand what this table means and how it's laid out? Of course, the table itself is that piece right there. And we added the total column and total rows onto it.
Just going back to the order possibility.
Yep.
Just to review, you add up both probabilities or both options.
Yep.
And divide by. Okay.
You just make sure you don't count the one twice, because this one was or high school or salary, right?
Yeah.
So that high school is all of these. Salary is all of these. You just got to make sure you don't add in that 6 twice. So that's why it's 114, 6, and 14. 114, 6, and 14. That's the high school people, the high school column. Now in the salary column, this 6 was already counted, so we're only going to do the 8 and the 18. So that's why I did 8 and 18 here. The other option, as we said, was you could take the two totals, the 124 and the 32, and you can add them together. Yeah, and then subtract out that 6 because that was in both of them.
Okay.
Well, the good news is I think you guys have had enough for the night. There is a new quiz that should be open right now that is due tomorrow, so Thursday, at 11:59 p.m. There is a new homework due for next Wednesday. You guys have a good week. The computer lab here is open next door if anybody wants to work on their quiz and get it out of the way.